Hello, so this is your first lab. I'm happy to be doing a chemistry lab online. I think this should be a lot of fun. Most of what we're doing here is very similar to what you would be doing if you were taking the in-person class. Actually, a lot of the activities can be done at home with some modifications to materials. So this is lab 1. We're working on averages and also standard deviations, or average deviation, as they call them in your book. So you have the option in this class to either print the lab directions off of Blackboard, or you can get a manual such as this that they'll be selling in the bookstore. I'm using this for guidance here. So you see some examples in your copy of finding averages and average deviations of water samples for water hardness, and they give you a good explanation of how they determined whether or not the two samples were different from each other. So your assignment for this lab is to choose 2 samples from your kitchen or from your house that by looking at them you can't quite tell if they have a significantly different mass from one another. When we do this in the laboratory, students weigh pennies. Pennies that were made before 1981 and after 1981, because the U.S. Treasury changed the material that they used to make the pennies out of. If you're able to find those samples, pennies from before 81 and after 81, you're welcome to do that as your experiment. That's a fun one. I chose to find the mass of 2 different types of lentils. Here we have split green peas, or split mung beans, and we have split yellow peas. And by looking at them, I can see that the yellow peas are larger, slightly larger than the green ones. So I might guess that if I weighed out, let's say, a half a cup of this sample, I might guess that this could weigh more, but I have to consider density. They could be larger, but they could be less dense. So I actually don't know by looking at these 2 samples. So I'd like you to pick something from your home or from your kitchen that you can weigh and determine if the 2 samples are actually different from each other. So the way to determine if they're actually different is not just by weighing one sample one time. We have to weigh at least 3 samples and find an average deviation, and a range of weights that sample could be. So I'm going to find out basically the maximum and minimum that yellow split peas could weigh from this bag, and the maximum and minimum that the split mung beans could weigh from this sample. So here I'll just show you the type of, so picking up where we left off, I was going to show you the type of scale that I'm using in this experiment. I got it just from Walmart. It was $5. You're also welcome to get a digital scale that shows digital readouts. For this experiment, I'm choosing to use this. I do have both, and I'll be showing the other in future experiments. So let's look closely first at this scale so you can get an idea of what I'm going to be looking at to take my measurements. A big part of this class is learning about taking measurements and making proper estimations. So you can see on this side of the scale, grams are shown, and the maximum weight that it can hold is 1,000 grams, or 1 kilogram. And it's split up by groups of 100. You can see that they show 100, 200, 300, and in between those groups of 100s, we see 1, 2, 3, 4 lines, meaning that each small line represents 20 grams. So when I'm reading this scale, I'm going to find out where my black measuring bar comes to, and I'm going to estimate as best I can in the tens place, because they're counting by 20 groups of 20 grams. So I'm going to estimate to the nearest 10 grams as I take my readings. So now that you can see what this scale looks like, I'll show an example of the experiment. So the first thing you have to do, and you will experience this when you do it on your own, the first thing you have to do is zero the scale. So as a chemist, I know it's important to be at eye level with whatever measuring device I'm using. And there's a nozzle on the back here that you can turn to either raise or lower that black bar that you were looking at so that we're starting at exactly 0. It should be equal with the 0 line. And I can see on my measuring cup, let me show you the measuring cup, that you can choose to measure either in cups or milliliters. I'm not sure how easy that is to see, but you can measure in cups or milliliters using this measuring device. So I'm going to use milliliters and grams, as that's what chemists use. That's what we're using in our lecture course for most of our calculations. It's the universal system of measurement. They use it in other countries, so that helps scientists communicate with each other. So we're sticking with milliliters and grams. Now, I'm going to measure out, let's say 100 milliliters for this sample. A milliliter is also equal to 1 cubic centimeter, so you're going to probably see that. And when we talk about solids, cubic centimeters are usually what we use instead of milliliters. So remember this throughout the course. 1 milliliter equals 1 cubic centimeter. And that's how we speak about solids. I'm realizing this may show up backwards on the screen. Okay, so I'm going to take my measurements and then we'll get to the calculations. So we have yellow split peas. I'm going to measure 3 groups of samples from this bag. So the first, I'll fill it to about 100 milliliters. And again, I get down to eye level to make sure I have a good, accurate measurement. And then I'm going to take my reading. So it looks like I see it's above 0. And it's 1, 2, 3 small lines above 0. So that means I have about 60 grams. And that's as accurate as I can be. I can't say 61 or 62 because the increments are in groups of 20. So the best I can say is to the nearest tens place. So I'm going to say I have 60 grams here. And I'm going to write that down. I have my data sheet here that you can either print online or use from your manual. And I have a note card I'm writing on myself. So I have 60 grams for sample 1. And I have to measure 3 samples of this to make sure I have enough information to get an average. So I'm going to try again, mixing it up so I might get different peas. And I have about 100 milliliters here. There's always some human error, which is why we measure the sample 3 times. Okay, and this time it looks like I have more like 70 grams. I'm going to write 70 grams. And I will weigh this a 3rd time. So as we do 3 different samples, not only are you getting 3 different groups of whatever it is you're measuring, but each time you add a sample to your measuring cup, you may be a little bit different as far as precision goes. You may measure exactly 100 milliliters, a little less, a little more. That's what we call human error, which is why we repeat experiments. So now this one, I see it looks to be about 50 grams. I'm going to do 3 repetitions for the sake of example. In your book, they give you space for 5 repetitions. I do recommend that so that you get a more accurate reading. For the sake of this example, I'm going to do 3 measurements of each type. So we're going to move on to the split mung beans. So I will measure out 100 milliliters. Okay, and it looks like I have 40 grams for the first sample. So if you're working with a scale like this, and you're working with solids, it's important to kind of level out what you have instead of keeping a mound there. That makes it easy for you to look and find out what volume you're dealing with. The other type of scale would be a digital scale. And that is something like this, something shown here. So I'll be using that for later experiments, but you can always use this and just choose two different objects, such as pennies before 81 and pennies after 81, to determine the difference in their masses. So you have two options here. I'm choosing to measure something in terms of volume. You can always also take, for example, if I had two different brands of markers, I wanted to measure 3 different markers using the digital scale, I would just set it on, write down the weight, do that 3 times for each type of sample, and then use those for my calculations. Okay, so on to sample measurement 2 for the monkey. And it looks like we have about 60 grams. Are these two samples looking very different from each other? To me, not so much. So we're getting closer to our answer about whether or not these two types of lentils weigh significantly different amounts. So now I get 40 grams again. Okay. Now with my data, I'm going to calculate the averages and the average deviations to determine if these two samples are different. So I will be posting a second video showing the calculations, and in the meantime you can gather your materials, maybe get your data, the masses of each of your samples in replicates of 5 as assigned in the lab manual, and then when you're ready to do your calculations you can click on the calculation video and follow along or read the directions in your manual. Good luck!